we are going to start the lecture on nanotechnology in chemical engineering. So, today we will discuss about the properties of various materials. So, the materials, if we convert that from bulk material to nanomaterials, so then the physical chemical properties would be change. So, how the physical and what are the physical or chemical properties that are very important for this nanomaterials. So, that we will discuss. So, here the properties of the nanomaterials may be physical, chemical or biological properties. So, physical properties, that is surface area, melting point, catalytic property, thermal property, that may be thermal conductivity or heat capacity, mass transfer property, means how that materials, once we convert into nanomaterials, how that would affect. And apart from that, there are some other properties, electrical properties, optical properties, magnetic properties of the materials, mechanical property of the materials and chemical property of the materials. So, from chemical engineering point of view, so here few property, so that is surface area, melting, catalysis property, heat transfer or thermal conductivity property or mass transfer property. So, that are the things we will discuss more details. So, today we will basically the physical property. So, surface area, melting points, excellent catalytic property, these are the property we will discuss. So, if you look into the publications, so in nanomaterials or nanoscience nanotechnology, so in the past few years or 10 years, you can see the number of publications considering these nanomaterials or nanostructured materials has been gradually increased and exponentially increased. So, here you can see that from 1980-85, from that to up to 2010. So, that exponentially that number of publications as per ISI wave of knowledge data that gradually increased. So, here we said if a bulk materials we have, let us say if we convert that into nanomaterials from a particular process or methods that we will discuss later. So, then the surface area of that material would enhance or increase. Okay, so that is one kind of physical property. So, in the physical property of the nanomaterial, that is the thermal property I said. Apart from that, there are hydrophilicity, hydrophobicity, suspension, settling, optical, mechanical and electrical properties that will be count as a physical property of the nanomaterials. And chemical property, when we are considering, so then oxidation, reduction, stability, sensitivity of the materials, toxicity and antifungal, antibacterial, disinfection, corrosive resistance or anti-corrosive resistance property. So, these are the various chemical property, so are there in nanomaterials. So, that is of course are dependent on the size of the materials. So, at what particular size in nano form, so we are preparing that materials. So, once it changes from bulk to nano, so then property of this property would be changes. Okay. So, a few property that we will discuss, that is based on chemical engineering point of view. So, many properties are there, but all properties is not possible to discuss. So, from chemical engineering point of view and interest, we will discuss those property. So, now there are other properties, melting point, density, thermal conductivity, these are the things we will discuss. And this changes means I said when we convert or change the bulk material into nano. So, these are the various physical property would change. Why nanomaterials vary so significantly by changing the grain size or particle size of that materials. So, here since the nanomaterials is nanostructured materials, it is composed of grains and grain boundaries. So, nanomaterials or nanosized grains contains thousands of atoms, few thousands of atoms for each grains. Okay, so in each grains there is grain boundary, and in the each grains there are lot of atoms are present in each grains. So, when we convert that bulk materials into a nanomaterials, so then what would happens? Then the size would be decreased of the grain size would be decreased. As a result, significant increase the volume fractions of the grain boundaries or the interface that would be changes. So, here since we have said that the nanomaterials, so means when it is changes from large or bulk materials into a smaller or nanomaterials. So, then in that particle size, that is bulk to nano, when it is changes particle size. So, surface area to volumes, that would be changes. So, as a result, the not only surface area to volume, so that would affect overall the electrical property, electrical transport, that may be changes. or maybe catalytic activity if that materials if we use in any reactions or any reactor as a catalyst, then catalytic activity that would be changes. Even if it is used in a electrical device, then electrical transports, that property also will change. So, how what are the grain boundaries? Suppose here you can see this is a bulk materials. So, here in that materials black circles and white circles, you can see that black circles, so that is the atoms, and white atoms. So, that is actually white atom that indicates grain boundaries, and so this is black one, that is the grains. So, if we change these bulk materials into a smaller ones, so then means bulk materials were converted into nanomaterials. So, then what are the defects or other things present in that bulk materials, that would be the defect in that material, bulk material is present when it is converted into nano, then these other things would be changes. So, therefore, what would happen? The mechanical, chemical and other properties, that every change, everything will be changes significantly due to the conversion of bulk materials into nano. So, that defects or other things, that everything will be changes. So, when we converted that bulk material into nano, so nanocrystalline ceramics or any other materials, so then these are the properties, so will increase, and density, elasticity, conductivity, that will decrease when we converted bulk material into nano. So, nano-sized nanocrystalline ceramics that are tougher and stronger than coarse grain materials. So, when nanomaterials exhibit significant increase in yield strength and toughness, that would be decrease, and at the same time opticals, magnetic property along with electrical properties, that also will change. Okay. So, here these are the things, few things we will discuss. So, for example, so here we can say, suppose we have a nickel. So, nickels, if we bulk materials of nickels, that if we bulk on that will convert into nanocrystalline lichens. So, then there are means let us say a nickels particles or materials that having 10 micrometers, that we are converting into 10 nanometers. So, here's bulk to nanocrystalline forms, we are making that nano nickel particles. So, then its hardness, strength, wear resistance, frictional coefficient, corrosion resistance, magnetic properties, electrical properties, hydrogen diffusions, electrocatalytic property, everything will change. So, hardness that would be increased 5 times, strength that 3 to 10 times, that will increase, wear resistance 170 times, that will increase if we convert that bulk materials to nanocrystalline materials. At the same time, frictional coefficients that would be reduced to half, and corrosion resistance that also will reduce, magnetic properties that would be lower the coercivity, and saturation magnetization that would be reduced by 5%. At the same time, electrical resistivity that would be increased by 3 times. So, and hydrogen diffusions or diffusivity that will increase, and electrocatalytic property that also will enhanced. Oh, hence that materials will be converted. So, here's I said that there are so many properties, a particular material that may be catalytic, electricals or any other properties. So, that would depends on the nature of the materials that we are preparing. So, surface, whenever we converted the bulk materials into nanocrystalline materials, then that surface property that will change. Okay. So, therefore, many things that would help, means keeping things in out, that would help allow the flow of a materials or energy whatever across the interface, that would assist or that would improve. At the same time, catalyst surface that can initiate or terminate for a chemical reaction, so that also will increase or improve when we convert that materials bulk into nano. Okay. So, sometimes the bulk materials, when you divide it into a nanomaterials or divided in number of nanomaterials, the total volumes remain the same. However, the collective surface area that would increase. So, here's the surface area, how that would affect when you converted that nano bulk materials into nano size, that we will discuss here. So, here for a examples, let us say a sphere of radius r that we have. So, that a bulk materials, if we convert that into a nanomaterial, so then how the surface area to volume that will change, or that would affect overall performance or property of the materials. So, here the surface area we can say that, and the volume of the sphere is this. So, when surface area to volumes we make a ratio, so then ratio of surface area to volume is AB equals to 3 by r for a spherical particles or spherical radius of r. Similarly, for a cylindrical material, so that is bulk to nano if we converts, and that shape of that materials may be cylindrical. So then if cylinder having radius r and height is h, then volume is this, surface area of this, and then surface area to volume ratio, that would be this for a cylindrical type of materials. So here if we compare, means do compare means from suppose a dimensions of that particles, so we said these two smaller diameters. So if we decrease the diameters or radius or length, so then for a spherical particles or cylindrical particle or cubical, whatever the particular shape of the particles that we have converted, means bulk materials into nanomaterials. So then if we change the dimensions from higher dimensions or larger 100 nanometer to gradually lower dimensions. So up to this you can see there is not too much changes of surface area to volumes, whatever the shapes, but after a certain changes we can see here in this particular locations sudden jump of the surface area to volumes that can be seen. Okay. Similarly in cubical also the surface area to volumes we can say that this. So here the means the changes means when we changes bulk materials to smaller or nano crystalline materials by considering particular method of synthesis or preparations method. So then the property of surface area to volume ratio that would change drastically. So here we considers means how the number of let us say cubes we have considered, it has dimension of one particular side is 1 meters each cubes, and number of cubes let us say ones, and its collective surface area would be this. So whence that we are converted into gradual smaller, means 1 meter in then 0.1 meters, then 0.01 meters, and then 0.001 meters, and then 1 nanometers. Means initially the particles or bigger size particles that was 1 meters in dimensions one side. So then it could be converted into smaller particles into dimensions would be 1 nanometers, A equals to let us say this. Then initially it was 1 cubes, then it would be converted into 2 to the 10 to the power 27 number of cubes. At the same time initially it was 6 meter square, that is the surface area, and when it would be converted into nanomaterials, then surface area is said that would change abruptly, means suddenly that jumps would you can see or you can notice increasing by changing the dimension of the particles. Okay. So surface area initially when it was let us say this, and then suddenly the surface area changes. Okay. Here we are considering let us say a spherical particles, we have the dimensions of radius is 10 micrometers. So we want to reduce that and that particular spherical particles and make 10 nanometers and radius of that particles. Then the total volumes, we if we consider that, assume that total volumes remain the same. So then as per 10 micrometers of sphere or spherical particles, that total volume that would become this, and when that we sphere converted into nano size, so then the volumes by considering 10 nanometer dimensions, so that is radius, so that would be this. Okay. So this is equivalence to 1 sphericals, and this is 1 micrometers, this is 1 micrometer sphere, this is 1. So if we make a ratio 10 volumes, we said that total volumes remain the constant. So if we make into ratio volumes of the 10 micrometers particles, volumes of the 10 nanometer particles, the ratio we can say that it would be this. So equivalence to n, total number of nano size particles that would be generated, 1 micrometers spherical particles we are converted into 10 nanometer size of particles, spherical particles. So then this number of particles, one particles converted into 9 times of smaller particles. So similarly if we consider the area also, means what would be the area changes, means initially I said the particle of spherical particle that we have considered that having 10 micrometer dimensions, that is radius. So if the surface area, if we measure or calculate the surface area, so that would be this, when that particles would be converted into nano size 10 nanometer particles, the surface area of one particles would be this. since by converting or changing 10 micron particles into 10 microns particles into 10 nanometers particles. So then this number of particles will be generated in nano scales. So then one particles having surface area this. So then 10 to the power 9 times of particles. So then total surface area by converting the particles into micron size particles into nanometers is this, and this is one particles having 10 micrometer surface area. So then we can say by changing the materials microns into nano, so then 1000 times the surface area will be increased. Okay. So that is the advantage or means dealing or working with the nanomaterials instead of bulk materials. So if we change bulk or bigger size of particles, convert that into nano, so then surface area would give means higher surface area we can get. So that would help many ways. So that we'll discuss. So that particular properties, how that would help or assist in a particular means applications. So now we'll look into the melting points and surface energy. A large fractions of atoms of nanomaterials each at the surface when we converted bulk materials into nanocrystalline materials. So then in that nanomaterials, so a large number of or large fractions of atoms that is present at the surface, and that influence the melting points of that particular material. So the atoms or molecules that is present at the surface that affect or means changes the property of melting point of that particular materials. Let's say if we prepare a materials having bulk size a particular metals and that converted into nano, even the property is the same, but means that nanomaterial that is also made of that same metal, but the melting points will affect, the melting points will changes. So melting point of the materials when it is converted into nano, so then the melting points of that materials will be lower, means initially the same materials that is in the bulk forms, when that converted into nano, the materials melting points will decrease. So that is maybe due to the surface, the energy means at the surface the energy that presents over the bulk materials and nanomaterials is different fractions of materials present. Therefore, the surface energy also will be changed. Therefore, the melting points or melting that particular materials will change melting property. So here's atom and molecules that is present at the interface that enhance the reactivity. Also means there is a tendency to agglomerates, means when we converted that bulk materials into nano, so then a large number of atoms would be present over the surface of that nanomaterials. So surface energy would be extremely high. So then there is a tendency of that materials, means nanomaterials, to agglomerates, means possibility is there. Those surface atoms and the molecules that is present, that is in the form of nano is present, that having high surface area and that molecules having high surface energy at the same times. So when we converted that bulk materials into nanomaterials, so large number of surface sites, atoms or molecules present at the surface, therefore high surface area energy will be present there, and there is a tendency to agglomerate or that molecules to stabilize, means when it is nano, so that is unstable. Okay. So then to get a stability, that molecules will means agglomerates, and then means there is a stability will generate. So when we converted that materials into bulk to nano, so then say how we can stabilize that material. So that is one possibility is agglomerations, means if we agglomerate that material, so then we can minimize the surface area energy, and then that nanomaterials will get stability. Okay. So means that is the way we can decrease or lower the surface energy by agglomeration. So that way nanomaterials will get stability. So here one examples we will show. So means the surface energy of bulk materials and nanomaterials. So what is the means the get an idea about that. Suppose we have a 10 identicals means nanoparticles. So that is actually means the materials having surface energy, and if we add them and make into a larger particles, so then overall surface energy how that would be changes, means when it is remains in nano and that would be converted into big particles. So then how the surface energy are different in two material made of same materials, but the surface area energy would be different. So here I said the surface energy in additive property. So here let's say cube A that having surface energy 6y, that is particular amounts, and if there is another cube that is also having the surface energy 6y. So two cubes, cube A and cube B, when we add them, So then the total surface energy we can get, let's say 12y. So each having 6y. So then when we add them, the total surface energy would be 6y. Okay. But whence these are the in nanoforms of materials, whence we make it into bulk materials by combining those nanomaterials. So then overall surface energy or total surface energy of this particle C, or here you can say that shape is parallelopiped. So here the surface energy would be at 10y. So these materials having surface energy 10y, and these two if we add, so 12y, so total energy. So of course this energy of surface energy of the nano size materials having higher than these materials. Okay. So at the same times we can say that the nanocrystalline materials means overall enthalpy of fusions, melting temperature, that also will change, that I said. So here if we change the bulk materials into nanomaterials, so then the melting points of that materials will, or that substance will decrease as we change or decrease the dimensions bulk into nanocrystalline materials. So then if we decrease the surface radius, so then melting points of that materials will decrease. So here one examples we can see. So here suppose we have a nano cadmium sulfide having dimensions 2.5 nanometers, its melting point is 600 Kelvin. Okay. So when it was in the bulk, that melting point was this. So when we converted that bulk into nano, so the melting points changes that way, means 1675 Kelvin into 600 Kelvin. So that way it is changes. Similarly, another example also you can see. So suppose you have a gold nanoparticles that have dimension 3 to 4 nanometer in size. So its melting points will be reduced or decreased by 500 degrees centigrade as compared to the bulk materials. So when materials it is present in the bulk form, so then the melting point will be higher. So and when that will be converted into nano form, that melting points will decrease. So here in the right hand side you can see that figure. So here's particle radius, larger particle radius, this is smaller radius of particles. If we change the radius of that particles, so melting points remains almost similar. So after that certain drops you can see. So whence that materials is in the nanoforms, so then surface energy would be high and materials tendency to agglomerate, and the same times melting points will decrease. So now we'll coming to the reactions where surface properties are important. So since once we conduct any reactions, then we have to use some catalyst. That catalyst may be metal, metal oxides or any other forms. So that catalyst we can use in the bulk forms or in the nano forms. So there is a lot of advantage when we are using in the nanoforms, that materials we are synthesizing and using for catalytic property as a catalyst in a catalytic reactions. So then since we have a bulk catalyst, at the same times we have nano catalyst, whence that materials would be converted into nanoforms. So then number of active sites, that is basically key component for a catalyst when gas and solid catalytic reactions if we consider. So number of active sites will increase, means the number of sites present at the surface will enhance. So as a result, cell selectivity of that particular material property we can see. So here you can see this is a bulk catalyst, this is, and this is nano size catalyst. So here you can see if these are the reactants. So two reactants that is attached with the surface of the bulk catalyst, since number of sites are less, and so when that would be converted into nanomaterials, that number of sites, I said number of active sites, surface sites will be increased, then number of molecules will be attached to the surface will be more. So as a result, if we means using that materials, if we want to develop any device that may be sensor or catalyst, so then number of responses would be higher in this case of nano size catalyst. Okay. So here few examples I am showing. So the shape of that catalyst also very important. So suppose if we do any oxidation reactions of CO by using gold nanoparticles having hemispherical shape in size, that is much more active than spherical ones. So these gold nanoparticles, if we make this type of shape hemispherical, that would be much more active gold than spherical shapes. So similarly for oxidation reactions of styrenes reactions, if you want to means oxidized, so then for to make a particular product using gold silver nanoparticles, so the nanoparticles shape is cubical shape. So that is much more for 14 times much more efficient, 14 times efficient than nano plates. Plates types, if its shape is plates, cube is much more efficient than nano plates, and similarly 4 times it is much more efficient silver nanoparticles in nano cubes is 4 times much more efficient than nano sphere. So the particles may be sphericals, may be plate types, or may be cubical types. So cubical types is much more efficient or much more effective, that would convert better results. Okay. So now if we use that materials, that is metal oxides, whatever that is in sensors, there also means the sensor can be used for or applications for any biological compound detections or specific chemical reactions. So then means this is our sensors. So number of sites, this is the active sites, surface sites of that particular sensors part. So suppose a gas, we have a number of components or molecules are present. If you want to detect particular red molecules, that would be interact with these surface sites. So if number of surface sites is more, so then the sensing efficiency or capability will be better, or that would be detections capacity will be enhanced. So here rate and accuracy of the reactions is improved when using nanomaterials rather than bulk materials. Okay, so means using nanomaterials for any catalyst or sensors or detections, that would give better performance or results than compared to the bulk materials. Okay, so today is up to this. Thank you.